All right, so now we're going to start talking about transformations of figures, right? So a transformation is a change in the figure, right? Now there are a couple changes that things can do, right? We can, there's my figure, right? I can, on this coordinate plane, right, I can just like move it around left and right, kind of like Tetris, right? I can rotate it, 360 degrees. I can flip it over like that. And another one is I could make this thing bigger or smaller, but keep it all in the same proportions. Okay, so the first one I talked about is called a translation. Right? A translation is when I just move it left, right, or up or down, right? It moves, but does not change its orientation. That means that all the points on all the vertices on this figure are all pointing or oriented the same way. Okay, that's a translation. Okay, another one is a rotation. Rotation. Okay, now this thing I can rotate it. I can rotate it about any point, right? But I'm going to rotate it about this point right here, right? So if I rotate it, that's like 15 degrees, 45 degrees, 90 degrees, right? That's a rotation. Okay, so if you notice, I could rotate it 180 degrees. I could rotate it, 240 degrees or whatever, right? So 270 degrees actually. Yeah. So that it moves. It changes orientation. Okay, and then I have a reflection. Imagine if I had a line right here, and it's gonna flip over this line, right? Or I had a mirror right here. It would reflect the image. Okay, like that, right? So this changes orientation too. This is a flip of the figure. Okay, so these are all similar in that the shape doesn't change size, it just changes orientation. Okay, when things don't change size and they just kind of move around like that, that is called an isometric. Iso means same, metric means measurement, right? Same measurement. Okay, because none of the measurements of the side of the lengths of this figure, right, or these angles here, none of them changed. None of them changed. Okay, right. And then there's a fourth one, and it's called a dilation. Okay, a dilation. It doesn't really. It's gonna change like location because it grows or it shrinks. Okay, this is a growth or shrink, right? And the angle measures, all of these angle measures here, like this one, this one, this one, and that one, the angle measures stay the same. The lengths of the side grow. Okay, and the only way that these angle measures can stay the same while the lengths of the sides grow is by all growing in the same proportion. Maybe they all double. Maybe they all are reduced by a half, right? But all of them have to change by the same amount. So sides change by the same amount or proportionally. Okay, so that's the 4 different types of transformations. This is not isometric. Isometrics, you can map isometrics figures onto another one, right? So mapping can be mapped onto a congruent, which means the line segments are all the same length and the angles are the same length. Well, the angles are the same measures, okay, on a congruent figure. All right, so we're going to do some examples here in the next video.